So hello, today I am going to discuss about the single stage amplifier. So basically the single stage amplifier means the amplifier which contained one amplifying device. Like here you can see here this a circuit diagram of a common source amplifier. Here you can see in the source terminal RS is connected. So this is a common source amplifier with degeneration. So now I will calculate the gain of this circuit. Okay, and this is useful when you solving a big circuit. Then if you can intuitively tell like what is the gain of this kind of circuit, then it will be easy for the analysis of the big circuit. Okay, now let's make the GMV model of this circuit. So this is a NMOS, like N-channel MOSFET. I will draw the GMV model of this MOSFET. So MOSFET basically a voltage control current source. So before drawing the model, I have to make the AC equivalent circuit of this model. So for the AC equivalent circuit, you just need to ground this one, remove VDD. Okay, now just draw the model. This is the gate terminal of the MOSFET. This is drain and this is the source terminal. Okay, if this is V1, then this voltage will be GM times V1, and between drain and source R0 is connected, where R0 is equal to 1 by lambda ID, where ID is the drain current, and this is RS, and here Vin is present. This is the RD, and from here we find the V out. Now in this loop you can write KVL. Let me change the pen color. I'm talking about this loop. Okay, so before that, the amount of current flowing through RD is V out by RD. So in this direction, what is the amount of current? Minus V out by RD. Okay, so here also minus V out by RD current is flowing. So what is the voltage drop here? Minus V out by RD into RS. Now if I write KVL here, I can write V is equal to V1 minus V out RD into RS. From this equation, I will find the value of V1, which is nothing but V in plus V out into RS by RD. Okay, now the amount of current that flowing through R0 is IR0, which is nothing but minus V out RD minus GMV1, because this GMV1 is flowing through here. Okay, so if I replace this V out by RD minus GM, and V1 is V in plus V out RS by RD. Okay, so now if I write KVL in this loop, then you can write V out is equal to R0 into V out by RD minus GM gain minus GM into RS by RD into V out minus V out into RS by RD. Now if you take common of V out, so it becomes 1 plus R naught by RD plus GM RS by RD plus RS by RD minus GM RO V. Now if you take common R naught in both sides, then equation becomes V out 1 by R naught 1 by RD here also 1 R naught will be present. Okay, V out R naught RD R naught by RD here 1 R naught will be present, so it will be GM times RS RD plus RS RD minus GM in. Now I am doing the rest of the calculation here. Generally the value of the RD tends to infinite. Okay, so you can write V out 1 by RD plus GM RS here 1 by R naught will be present. Okay, so this term will be cancelled out, so GM RS by RD minus GM V. So our gain V out by V is equal to minus GM RD by 1 plus GMRS. Now in the numerator and denominator, if you take GM common, it become RD by 1 by GM plus RS. So this is the formula, the gain of this structure, where we consider R naught tends to infinite. So how you can remember this? So it is easy to remember. For the common source circuit with degeneration, the gain will be, the magnitude of the gain will be total resistance in the drain terminal, total resistance in drain terminal divided by 1 by GM plus total resistance in the source terminal. So this is basically the formula you can remember or you can apply to solve this kind of problem. Okay, now what I do, actually this is a common source circuit here, so instead of taking V out here, we will take V out from here, so it will become common drain circuit, and I am going to find value of the gain of this circuit. Okay, so now let's draw the model here. So this is the gate terminal where gain is present, the drain, this is the source, so this is GM gain, here R naught is present. Here actually I am ignoring the effect of the body bias. Okay, here V out is present, RS, this is, sorry, this will be V1, not V in. Okay, so this is V1 and this is RD. Okay, now let's solve the problem. So you can write KVL here. So V in equal to V1 plus V out. So V1 is equal to V in minus V out. So amount of current flowing through here is V out by RS. So the amount of current flowing here also it will be V out by RS. Okay, so current flowing through R naught, which is I R naught, is V out by RS minus GM V in. So V out by RS minus GM, sorry, instead of V in it will be V1. So GM V in minus V out. Okay. Now if you write KVL in this loop, you can write as V out by RS into RD plus IR naught. IR naught is V out RS minus GM V in minus V out into R naught plus V out. Okay, so now if you take V out common, it will becomes RD by RS plus 1 by RS into R naught plus GM R naught plus 1 is equal to GM V into R naught. Now take common R naught in both the side. So I actually want to remove the R naught from here. So it will becomes V out RD RS into 1 by R naught plus 1 by RS plus CM plus 1 by R naught is equal to GM V in. As R naught tends to infinite, so 1 by R naught tends to 0. Okay, so our equation becomes V out 1 by RS plus GM is equal to GM V in. So V out by V in becomes GMRS by 1 plus GMRS. Now if you take common GM the both numerator and denominator, it will becomes RS by 1 by GM plus RS. So to remember this formula, just remember what is the total source resistance divided by 1 by GM plus total source resistance. Okay, so generally the value of the RS is much greater than 1 by GM, so the gain becomes almost 1, so it becomes a voltage follower circuit. So you can intuitively see also, like if you increase this voltage, okay, so what will happen, VGS increase, so which will increase the current. So this terminal voltage also increase, which decreases overall VGS, so make the current constant. So that's the use of the resistance RS here. It provide the stability, provide a negative feedback in the circuit. Okay, now I'm going to calculate the gain of this configuration, which is common gate. Now let's draw the model of the circuit. So before this I have to remove this VB and make it AC ground, and this also I need to make AC ground. So our circuit will look like gate terminal connected to the ground. This is V1 and this is GM V1, and here Vin is connected. This is R0 and here RD is present, and this is the V out. So we can write V1 plus Vin is equal to 0. So V1 is equal to minus Vin. So if you write KCL in this node, what you can write? Like V out by RD, outgoing current. This is also outgoing current. All three are outgoing current. V out by R0. Sorry, V out minus Vin by R0 plus GM V1 is equal to 0. So V out 1 by RD plus 1 by R0 is equal to Vin by R0, and when it comes to this side, right side, it will become minus GM V1, and you also know V1 is equal to minus Vin, so it will be GM Vin. Okay, so V out by RD parallel R0 is equal to Vin 1 by R0 plus GM. So 1 by R0 will be much smaller as compared to GM, so you can write V out by Vin as GM RD parallel R0. So this formula you need to remember to solve the next problems, and this also some output impedance I am going to calculate, which will help us later. So this structure called as a diode connected device because it looks like a diode structure. Okay, so what is the output impedance offered by this structure? Let's calculate this. So first draw the model. This is the gate terminal, this is the drain, the source, so this is V1, this is GM V1, this terminal is connected to the ground, here R0 is present, this is test voltage, and this is test current. We need to find Vx by Ix, so you get the impedance. So here this terminal is connected with this terminal drain, so you can write V1 is equal to Vx, and if you write KCL in this node, so what you can write? So incoming current is Ix and outgoing current is Vx by R0 plus GM Vx. So Vx by Ix is equal to 1 by Rho plus GM. So 1 by Rho is very less value is compared to GM, so it will become 1 by GM. Okay, now in this structure I am trying to solve intuitively. So for AC analysis, this terminal becomes 0. So here if you connect Vx and Ix, here suppose R0 is present. Okay, so here you can see the value of the VGS is 0 because gate and source terminal both are connected to the ground, so no current flowing through this transistor. So GM into VGS is 0, so current is 0. So total current, that the Ix current will flow through this R0 resistance. So you can write Vx equal to Ix R0. So Vx by Ix is equal to R0. Now for this structure we need to calculate the output impedance. Okay, so for this we need to draw the model. just connect with ground, and this is Vx, this is Ix, GMV1, this is R0, and here R is present. Here we can write V1 plus Vx is equal to 0, so V1 is equal to minus Vx. Now what I am going to do, so if this current is Ix, so this current is also Ix, and what is the current flowing through this here? Ix plus GMV1, so it will becomes Ix minus GMVx. Okay, so now just write the KVL here in this loop, right? If you write KVL in this loop, it becomes Vx equal to R0 Ix GMVx plus Rix. So Vx, if you take common, it becomes GMRO. Now Ix into R0 plus R. So Vx by Ix becomes R0 plus R by 1 plus GMRO. So this GMRO has a specific name. It is called intrinsic gain. So this is the impedance of the structure. Okay. Now here we also have to calculate the output impedance. Now I will try to solve this intuitively. Okay. So here we connect ground because I am doing the AC analysis. So this is the test voltage. Actually this is a rule, like when you are calculating any output impedance, just make the independent sources which are present in the circuit inactive. So to inactive the voltage source, we make it 0, or which is short circuit, or to inactive the current source, we make it open circuit. So here voltage source is present, so that's why we connected it to the ground and make it short circuit. So Ix current is flowing through, and this is the RO present internally. So this Ix is also flowing through here. So what is the voltage here? It will be Ix time Rs. So what is the VGS of this transistor? 0 minus Ix/Rs. So minus Ix/Rs. So what is the current flowing from drain to source terminal? ID is equal to Gm times VGS. So minus Gm Ix/Rs. Okay, so the amount of current flowing through R0, which is IR0, it becomes Ix minus ID becomes Ix plus Gm Rs into Ix. Now if you write the KVL, what you can write? Vx equal to R0 to Ix plus Gm Rs into Ix plus Ix/Rs. So if you take Ix common from this side, it becomes RO plus GMRS, RO plus RS. So Vx by Ix becomes 1 plus GMRO 2RS plus R0, or equivalently you can write as GMRO into RS. So you need to remember this when you solving this kind of problem. Like easy way to remember this, like the intrinsic gain of the transistor multiply with the source resistance. Okay. Now let's solve this problem. Let's try to solve this problem intuitively. Okay, so here VDD is present, so for AC analysis we will make this to ground. So here Vin is present and 0. So what is the value of the VGS, which is Vin? So amount of current flowing from the drain to source terminal, nothing but GM times Vin. Okay, now if you write KCL in this node, like output node, so what you can write, what is the value of the outgoing current? GM Vin. In this direction, what is the current? Plus V out minus Vin by RF plus in this direction, what is the current? V out by RD. Let us assume R naught tends to infinite here. Okay, so here this is the expression. Okay, now take the V out common, it becomes 1 by RF plus 1 by RD, and if you take minus V in common, here it becomes GM minus 1 by RF, so V out by V in becomes minus GM minus 1 by RF into, it will becomes this side it becomes RF parallel RD. Okay, so this is the answer. Now you can solve intuitively this problem also. So this terminal connected to the ground, so what is the VGS here? Value of the VGS is 0 minus Vin, so 1 minus Vin. So ID becomes GM into VGS, so GM into minus Vin, so minus GM Vin. Now here is the current ID. So now just apply KCL here. So here all the current are outgoing current, so just write the KCL. So minus GM V in plus V out minus V in by R1 plus V out by R2 is equal to 0. Now take the V out common here, 1 by R1 plus 1 by R2, and take V in common here, it becomes 1 by R1 plus GM. So what is the gain? V out by V in is equal to 1 by R1 to GM to R1 parallel. Okay, now let's look at the next problem. Now what will be gain of this structure? Okay, so we can do one thing. We can consider or may not consider R not here. Now let's consider in this case. So suppose R naught is present here, R naught and this R naught have same value. Okay, now VGS from M2 is what? For M2, VGS is V in minus V out. So the current ID becomes GM2 into VGS, which is V in minus V out. For M1, what is the value of the VGS? What is the value of the VGS? It's V in minus 0, so V in. So what is the value of the ID? GM1 into V in. Now just apply KCL here. So what is the incoming current in this node? GM2 V in minus V out. What is the outgoing current? minus gm1 into vin, and in top direction what is the output current? V out by RO. In the bottom direction V out by RO. So take Vin common here, which is gm2 minus gm1, and V out common here, it becomes gm2 plus 2 by RO. So V out by Vin becomes gm2 minus gm1 by gm2 plus 2RO is the value of the voltage gain here. Now you can also calculate the gain of the structure. So I am doing some part, and you can do the rest of the part. Let take this voltage as Vx. Okay, so what is the current flowing this terminal, which is Gm time Vx. As this terminal voltage is Vx, so this terminal voltage is Vx. So what is the value of Vsg? 0 to Vx 1 minus Vx. So Gm times Vsg current flowing in this direction, downward direction. So at Vsg is negative, so actually current flowing in upward direction. So the value of the current is Gm2 into Vx, and here the value of the current is V out minus Vx by RT. So all these current are actually same, so you can write like Gm2 Vx is the outgoing current plus V out minus Vx by RT is equal to 0. So take Vx as common, so Gm2 minus 1 by RT, 1 minus V out by RT. So you get some value of the Vx here, and in this node write another KCL, so it becomes Gm Vx is equal to V out minus Vx by RT. So just solve these two equations, you get the value of V out by Vin. You can do it as a homework. Now let's try to solve the next problem. Okay, so this is an interesting problem. Okay, so if I assume this terminal voltage as Vx, so this voltage becomes also Vx. So the current flowing here is minus Gm2 into Vx. Okay, Gm2 into Vx. And what is the value of Vgs here? The value of Vgs here is Vin minus Vx. So what is the current flowing through drain to source? Gm1 into Vin minus Vx. Okay, here this amount of current is flowing. Now if you consider R0 here, R0 is connected here, so amount of current flowing in this direction is V out by R0, and here another R0 will be present. The amount of current is flowing in the downward direction is V out minus Vx by R0. Okay, now you need to solve this equation. So what are the equations that we are getting if you write KCL in this node? Let's focus on the outgoing current first. Okay, so one outgoing current is V out by R0 plus this outgoing current, V out minus Vx by R naught, this outgoing current which is Gm1 Vin minus Vx, and what is the incoming current is equal to minus Gm2 Vx. This is one equation, and another equation you can write as like mm, Vx is equal to this current which is Gm1 Vin minus Vx plus V out minus Vx by R naught into Rs. So now if you solve this equation, you will definitely get the value of V out by V in. Okay, this is a lengthy equation, so you can easily solve these two equations. Just calculate the value of Vx here in terms of V1 and V out and V in, and substitute here. Okay, so you can easily find what is the value of the gain. And here you can see this is a common gate structure, and this whole structure is connecting as a load resistance. So what is the value of this load resistance? If you look this terminal, this is nothing but acting as a current source load whose resistance is RO3. So what is the equivalent resistance? If you look in this way, it will be 1 by Gm2 RO2 into RO3 plus RO2. I derive in the previous slide. You can go or look into that slide. So equivalently it becomes Gm2 RO2 RO3. So what is the gain of this common gate structure? It is nothing but Gm1 into Rd. Here Rd is Gm2 RO2 into RO3. So in this way you can easily find the gain here. So if you don't know what is the output impedance of this, so you have to again draw the model, and then the circuit becomes big and it will be difficult for you to calculate the value of the gain. If you know the structure output impedance, then you can easily find what is the gain of the circuit. And there is a few problem. Okay, so this circuit, you can see this looks like a common source amplifier with regeneration. The above, it is a diode connected device M3, and bottom it is also a diode connected device. So top the impedance is 1 by Gm3, the bottom impedance also 1 by Gm1. So what will be the gain? I am told. So minus total impedance in the drain side, which is 1 by Gm3 by 1 by Gm2 plus total impedance in the source side, which is 1 by Gm1. So you can see, you can easily solve this problem. Here you can see, here Rd and Rs is simply replaced by a current source load. So if you look above, what impedance you are seeing? RO3. Look bottom, what impedance you can see? RO1. So what is the value of the gain? So minus Rd, which is RO3 by 1 by Gm2. What is the impedance shown in the source side is RO1. So this is the gain of the structure, which you can easily find intuitively. And this technique is useful when you are solving like gate problem or any kind of interview. So now you have to calculate the gain of this structure. So you can basically see This is basically uh, a common drain structure. This is the value of the RD, which is RO3. This is the RS, this is RO1. You can remember the formula of the gain, which is source resistance by 1 by GM2 plus the value of the source resistance. And this is another problem. So you have to think that how you can solve this problem. So just take this voltage Vx here, so this will be also Vx. So this current will be minus GM3 into Vx, and here you can take RO also. So some outgoing current will flow in this direction, and here also a RO resistance is present. So for GM, here some current like GM2 minus GM2 into Vx, and here the current will be GM Vin. So you can easily solve multiple number of KCL equation and get the result. Okay, this is the another problem. You have to first have to find the impedance of this structure, then find the gain. So let's try to find the impedance of this structure. Okay, so I am drawing the AC equivalent circuit. So this is the Vx, and this is Ix, and this point voltage is also Vx. The amount of current flowing is in this direction will be GM3 into Vx, and here the current will be GM2 minus GM2 into Vx. So you can write like GM2 Vx is equal to GM3 Vx. So GM2 becomes GM3, and you can also write like Ix is equal to GM2 Vx. So Vx by Ix is equal to 1 by Gm. So what will be the gain of the circuit? So minus Gm1 into 1 by Gm. If Gm1 and Gm are same value, then it becomes minus 1. So you try to solve this problem as a homework. So this is all from this video. If you have any doubt, let me know in the comment section.